Okay, here we go. Rational expressions. Rational expression is the quotient of two polynomials. It's a fraction. Polynomial in the numerator, polynomial in the denominator. That's a rational expression. We're just dealing with expressions today. No equations because there will be no equal signs. Okay. Domain restrictions. This is important. Eliminate variable values that result in division by zero. You're not allowed to have zero in your denominator. So we talked about extraneous solutions in some previous chapters. That's one of the things we need to watch for here. What are we not allowed to have? What makes our denominator zero? If we get zero in our denominator, that is not okay. We're not allowed to have that. So if we end up solving a problem later on, and we get like x equals 2, but if 2 makes our denominator 0, that's not a solution. You have to pay real close. There are a few places where domain come into play. Square roots, you're not allowed to take roots of the negative. And denominators, anytime you have a fraction, you're not allowed to have 0 in your denominator. There are a few other things that you need to worry about domain, but those are the two big ones. Anything that makes your denominator 0, anything that makes a radical negative. Those are the two things you don't want to deal with. Okay, and we're going to talk about those in here. Okay. Opposites. This is kind of important when we're coming up later on, when we do our factoring and reducing. Finding opposites in order to be able to reduce. Okay, the opposite of x minus 2 is 2 minus x, or negative x plus 2. We may want to change the sign and get an opposite in order to be able to reduce. The opposite of 5 minus n minus 5, or negative 5 plus n. Change the signs. We're going to look for those opposites for reducing purposes when we reduce our fractions. And most of today is about finding the simplest form, which is reducing a fraction. Oh, excuse me. So pretty much today is all about reducing fractions. Okay. Questions so far? Okay, first examples. Simplify and list any domain restrictions. I actually like to, in this particular case with these two, list my domain restrictions first. My domain restrictions come from anything that will make my denominator 0. So in my first example, what values of x and what values of y are going to make my denominator 0? Yeah, if x is 0, so x can't be 0. Because if x is 0, I get 0 in my denominator. I'm not allowed to have 0 in my denominator. It's undefined. Okay. Y also cannot be 0. And it's often easier to say what something cannot be than what it can be. Okay. It's often easier to say with domain restrictions what it can't be than what it can be. It can be everything but 0. It's easier to say it can't be 0 than it can say it's everything except 0. Does that make sense? Okay. So that's our first step. I like to do domain restrictions first. Sometimes you can't. We'll have some examples here where you can't. But I do them always before reducing. Okay. So now I reduce, and you just reduce like we've done before. I look at my numbers, 24 and negative 6. I look at them, and I just do that, 24 over negative 6. That reduces. 6 goes into 24 evenly, so that gives me negative 4. Okay. And then I look at each variable. When I only have variables, I look at them as I go along. So I have x cubed over x squared. Well, 3 minus 2 is 1, so that means I have x to the first, which we don't write the first power because we don't write 1 if we don't need to. And then I have 7 and 2. What's 7 minus 2? 5. Where does y to the fifth go? In the denominator, because that's where this 7 was, the larger exponent. 4x over y to the fifth. Simplify. And we've done like this already before. So this one's not really all that new. The big new thing we're talking about is our domain restrictions. Okay. What are our restrictions on this one? X. What other variables do we have in our denominator? Y and Z cannot be 0. We're not allowed to have 0. These are easy for your domain restrictions because there's no factors. It's just, you know, the variables. Okay. Now we do the numbers. 2 and 16. 2/16 reduces to 1/8. I'm not going to write the 1 unless I have to. If I have anything else in the numerator, I don't have a 1, but let's say everything else ends up in the denominator, then I'll put a 1 on top at the end. Okay. X cubed, x to the 5th. 5 minus 3 is 2. Put x squared in my denominator, because that's what the 5 was. Okay. 2 minus negative 2. 2 minus negative 2. 2 minus negative 2 is not 0, it's 4. Where does it go, numerator or denominator? Numerator, because it goes where the bigger one was, and 2 is bigger than negative 2. So that means I have y to the 4th. And then 3 minus negative 1 is 4, and it goes in the numerator, z to the 4th. Larger power, where my answer goes when I just subtract the smaller one from the big one, and that's where my answer goes is that. Okay. Questions?
Wait, why would it be 4 and not
3 minus negative 1. Okay, and yes, I do write them on the board like this because if you're doing it in your head, sometimes it's easy to screw up. 3 minus a negative 1. That's actually 3 plus 1. Feel free to write it off to the side like that. I do. Okay. Your turn. Do these problems. Okay, it looks like everybody is done or close enough for government work. So my domain restrictions, once again, this is easy. Anything in the denominator. X, Y, and Z cannot be 0. Easy enough. And then just start doing the reducing. 14 and 21, 2/3. So I have negative 2 over 3, and then fill in the rest as I can go along. 7 minus 1, x to the 6. 6 minus 4, y squared. And the last one, the z is interesting. What's bigger, 0 or negative 3? 0. What's 0 minus negative 3? 3. Where does it go? In the denominator. Excelente. Z cubed. Okay. Okay. Next one, same thing. A, B, and C cannot be 0. That's my domain restrictions. 25 over 80. Those divisible by 5. So you get 5 over 16 for the 25 over 80. Look at the A's. 5 minus 2 is 3. A cubed. 2 minus negative 3 is 5, and it goes in the numerator, so I have b to the 5th. Negative 2 minus negative 4. Negative 2 minus negative 4 is 2. So I have c squared in my denominator. Okay? We're good so far? Because it's going to get harder. I know. Mr. Artis, you always say that. Yeah, I do. I'm usually right. So, reducing fractions. Simplify and list any domain restrictions. I can't list the domain restrictions of this one as it stands. I need to know what makes my denominator 0, which means I have to factor first. And you're going to want to factor these anyways. This is why I had to do the factoring worksheet to practice for this stuff. Okay? So my first step here is actually factor your numerator and denominator. That's the first thing you do, is factor them both. So I have a squared plus 2a minus 8. Two numbers that multiply to give me negative 8 that add to give me positive 2. 4 and negative 2, so I have a plus 4 over a minus 2. And then the denominator, same thing. Two numbers that multiply to give me 12 that add to give me sorry, multiply give me negative 12, add to give you positive 4. A plus 6, A minus 2. Now that I've factored, I look at my denominator, what's going to make my denominator 0? A can't be negative 6. A can't be 2. Negative 6 will make that 0. 2 will make that 0. A can't be 6 or negative 2. So I found my domain restrictions. I factored to prepare for simplifying. Now, when you are simplifying a fraction, the things that you cancel in your numerator and denominator are things that are multiplied, never things that are added or subtracted. Right? If I have 4/8, I can reduce that because this is 4 times 1 and this is 4 times 2, right? So I cancel the 4, so I'm left with 1/2. I don't think of this as being 4/8 as being, well, that's 3 plus 1 and 3 plus 5. And I cancel my 3, so I get 1/5. We don't do that, right? It's not what's added or subtracted, it's things that are multiplied. That's what you cancel, things that are multiplied. So when I have this, what do I cancel? I cancel things that are multiplied. This is A plus 4 times A minus 2, A plus 6 times A minus 2. My factor, the things I'm multiplying, my factors that are in common, are the A minus 2s. That's what reduces. My factors are what I cancel. So my answer is A plus 4 over A plus 6. That cannot be reduced anymore. You can't go, oh, there's an A in the numerator and an A in the denominator. You can cancel them because those are being added. They're not being multiplied. I can't go, oh, 4 over 6, that reduces to 2 over 3. You can't do that because they're not being multiplied. They're being added. Only things that are multiplied are being added. And I guarantee if this were a test question, somebody would keep going. They get to here and they go, oh, I can do more, and they can't. I guarantee it happens all the time. It's only things that are multiplied that get reduced. There is no multiplication going on there. No more multiplication. There's multiplication here, right? This times that, multiplication. That I can cancel. Addition and subtraction, you cannot do that. Okay? So if we look at this one here, move it up a little bit, and I want to factor. Okay. So I factor out a 4 in my numerator. 4 times 3 minus c. My denominator is the difference of 2 squares. C minus 3, C plus 3. Okay. I factored, not yet reduced. What can C not be? What's going to make my denominator 0? 3 and negative 3. 3 and negative 3. I always use the factored form to decide what I have. Now, can I reduce? I can, but is it easily seen? Remember this? Opposites. Sorry. Opposites. C minus 3. What is the opposite of, what's the opposite of 3 minus C? C minus 3. I can change this. So I get 4 and C minus 3. But if I change this to the opposite, it means I need to bring it negative out front. If I have something that's the opposite of what I want, I can swap it, give me the opposite, but I have to put it negative in front to deal with it. Okay? And then I have C minus 3, C plus 3 in my denominator. Now I can reduce. my minus 3's cancel. And my answer is negative 4 over C plus 3. Okay. See why I said factoring was such a big deal? We're going to be doing a lot more of this stuff. Factoring is a very big deal for what we're doing today. Okay. Your turn. Do those two. I think there's only 2 there. Yep. Do those 2. Okay, so let's do these. Your first step is to factor and use those factors to decide what your restrictions are. So 2 things multiplied to give me 10 and add to give me 7. M plus 2, M plus 5. And my denominator, same thing. 2 numbers that multiply to give me 12. That's negative 12 that give me negative 4. And here's a hint. More than likely, one of your factors in your numerator is going to be one of your factors in your denominator. So more than likely, it's not going to be 5, because 5 times something doesn't give you 12, but 2 times 6 does. That should give you a hint, right? So you get M plus 2, M minus 6. Generally speaking, that's a good hint to look at. If you can factor one easily, factor your numerator or denominator, that should give you a hint for the factors of the other one. Okay? What can M not be? 6 and negative 2. M cannot be 6 and negative 2. And then I do my reducing. The M plus 2's cancel. And I get M plus 5 over M minus 6. Okay? Same thing on the next one. First thing you want to do, factor it out. The top one, it's not a quadratic, but I do have a common factor of 3. Pull out 3, and I get 2 minus x. On the bottom one, difference in squares. X minus 2, x plus 2. In my domain restrictions, x cannot be plus or minus 2. Then you can write 2 and negative 2 or negative 2 and 2, or do like I need to do plus or minus 2. Either way is fine. Now, I don't have a direct cancellation, but I do, however, this is the opposite of x minus 2. So if I put a negative out in front, I can switch 2 minus x to x minus 2. Now I can reduce. These cancel, and I get negative 3 over x plus 2. Questions? And if they're both positive, just move them around. You don't have to worry about being opposites. They're both positive. It's only if you have one negative you have to worry about the opposite thing. Okay. Any questions? Not, like I said, it's not hard, but you got to be able to factor. Factors, and you got to be careful. Okay. All right, now we're going to step it up a notch. Multiplication. I can't move the b by itself, so I'd move that if I could. Okay. So, your first step in multiplying fractions is to factor every fraction. Factor them both. That's your first step when you're multiplying fractions like this. Factor them. Okay. So I have 2y minus 8. I can factor out a 2. 2 times y minus 8 over y squared. Oh, sorry, not y minus 8. That was my bad. That would be y minus what? 4. Thank you. Factor y squared minus 16. Difference of squares. Y plus 4. Y minus 4. And that's times. Factor out the other one. Y squared plus 2y minus 8. 2 numbers multiply, give me 8. Subtract to give me 2. 4 and negative 2. Y minus 4. Y plus 2. And then I factor the other one. Y squared plus 8y plus 16. Two numbers multiply to give me 16 and add to give me 8. 4 and 4. That's technically y plus 4 squared, but for our purposes here, it's actually better to write it as y plus 4 times y plus 4. It works better for what we're doing here. Okay, I don't know for sure, but you always want to do that. Write out every factor. Makes it easier. What are our domain restrictions? Y cannot be what? Yeah, plus and minus 4. There are no other domain restrictions because those are the only things that make the denominators 0. Now comes the fun part. Anything in the denominator that can cancel with anything in your numerator. Sometimes it's a lot, sometimes it's a little, sometimes it's nothing at all. So I look for any factor in my numerator that cancels with any factor in my denominator. I cannot cancel two things in the numerator unless I have two matching things in the denominator. So for example, I have a y minus 4 here, and I have a y minus 4 here. Do I have anything else in my numerator that matches something in my denominator? No, I have two things in my denominator that match each other, but they're both in the denominator. They do not cancel out. My answer is everything else that's left. 2 times y minus 4 times y plus 2 all over y plus 4 times y plus 4 times y plus 4. Please, dear Lord, do not try to multiply that all out.
For y minus 4 and then y plus 2, wouldn't it be positive 4 and negative 2 because of negative 8 and 2? That would add to the
Well, now you wait to tell me now when I've already done everything else. No, you embarrass me in front of every. Oh my God. So yes, her point is this should be plus 4 and this should be a minus 2, which means that if I back up here, oh, those cancel out there, which means that I can get rid of this would be gone because I don't have the y minus 4, and that will be gone. So I end up with, in the end, in my final answer, erasing all the crap that's not there, 2 times y minus 2 over y plus 4 times y plus 4. No, I'd rather, I'd rather have you catch it and fix the mistake rather than keep going and look like an idiot. Now, I did that on purpose. You believe me, right? That I did that on purpose to see if you were paying attention, right? Yeah. Isn't that what teachers say? And what do you always think whenever they say they do it on purpose? That they're full of crap. Okay. Questions on this one? Okay. What's the difference between multiplication and division? How do you divide fractions? How do you divide fractions? Invert and multiply. Which one do I invert, the first or the second? Second fraction gets flipped. However, we need to factor first before we do our flipping because we have to check our domain restrictions twice. We have to check it now, and then we have to check it again on our original answer, our final answer. Our final answer has not been an issue before because we haven't had to do any inverting. But when we invert, if we end up with a new thing that doesn't work in our final answer, we have to add that to our restrictions. So the first thing you want to do is factor both of them. And ladies, you guys need to go on since anytime. Good luck. Okay. So first thing, factor each one. M plus 4, M plus 1 over M plus M, not X. M plus 4, M minus 3 for the first one. Divided by M squared minus 1 is M plus 1, M minus 1, and factor out a 2m. 2m times m minus 3. Okay. Domain restrictions, I need to do it twice. I need to do it now, and then I need to do it after I finish my division. Check to see if there's anything new in my denominator that wasn't there before that gives me a domain restriction. So my domain restrictions, m cannot be -4, +3, and 0, right? -4, 3, and 0. And -4 will make this 0, -3 will make, 3 will make that 0, 0 makes that 0, and we already covered this 3 here. Okay. Factor, check domain restrictions. My next step is to invert and multiply. Now, if you want to rewrite the whole problem again, feel free to rewrite the whole problem again. If, however, you just want to say, oh, I'm going to invert this, that means I have 2m times m minus 3 here, and m plus 1 and m minus 1 here. That's what it is inverted. You can just do that. Instead of dividing, now I'm multiplying. Invert, multiply. Multiplying, what do? I cancel. Anything in the numerator I can cancel with anything in the denominator. Now's the time to do it. Okay. So I have m plus 4. Nope. Oh yeah, m plus 4, m plus 4. Woohoo! M plus 1. Ooh, m plus 1, m plus 1. Yay, things are looking up. M minus 3, m minus 3. I only have 2 things left, 2m and m minus 1. So my answer is 2m over m minus 1. Do I have any new domain restrictions in my final answer? Yes, m can't be 1. All of those domain restrictions apply, both in the original problem and in our final answer. Because we're never at any time allowed to have 0. Not when we start, not when we end. Okay? In between's okay, but not when we start, not when we end. Your turn, do those 2. Okay, so first thing we need to do is to factor these. I'm going to move to this one for my way first. First thing you do is factor. So 3y minus 6 is 3 times y minus 2. What's your minuses and pluses? Minus 2. My denominator, plus 6 minus 5, y minus 2, y minus 3. Times 2 numbers to give me 10, let's subtract to give me 3, y plus 5, y minus 5, y plus 2. My bad, y minus 5, y plus 2 over y plus 2, y minus 2. Is that good? So I screwed a couple of them, so make sure I got it right. So I was messing them up. My bad. Okay, my domain restrictions. Plus and minus 2 and 3. Y can't be plus or minus 2 or 3. And now I get to have the fun part of canceling. Minus 2, minus 2. Plus 2, plus 2. I don't see anything else. Do you see anything else? Okay. So I have 2 times y minus 5 over y minus 3, y minus 2. Not too bad. Right? Questions?
What did you choose? On the top. No, on the answer.
This is a 3. It was always a 3. It was always a... These are not the droids. Smart ass kids. Okay, this one's a little tougher, but it's not too bad. 2m minus 1, I can't do anything to that. So I do want to rewrite everything that I do. 2m minus 1. Factors of 10, subtract to give me 3. M minus 5, m plus 2, divided by difference of two squares. 2m plus 1, 2m minus 1. That's not an easy one to see. 2m plus 1, 2m minus 1. All over, and I can factor a 4 out of this. 4 times m plus 2. My domain restrictions. 5, negative 2, negative 2. So m can't be 5 or negative 2. At this time, those are all my restrictions. Now, invert the second fraction so I can multiply. And just rewrite it, flip it over, rewrite it upside down. 4 m plus 2, 2m plus 1, 2m minus 1. Those are gone, and that's now multiply. Cross cancel and reduce. m plus 2, m plus 2, 2m minus 1, 2m minus 1. Anything else? Okay. I have a 4 left in my numerator, and a m minus 5. That's a 4. And 2m plus 1. I've already got the minus 5 taken care of. Can't have 5. But what about the 2m plus 1? What does this is one that's going to trip up a lot of people for not allowing to be 0, right? So if you're not sure, if it's not an easy one to see, here's what you do. Take that 2m plus 1, set it equal to 0, and solve. Right? Take whatever it is, set it equal to 0, and solve. Subtract 1, 2m equals negative 1. Divide by 2, m equals negative 1/2. So that means I can't have negative 1/2. It's also in my domain restriction. If you're not sure, if it's not readily, easily seen, just take that factor, set it equal to 0. Okay? Questions? You've been a wonderful audience.